Today's topic of discussion is Turing Machine. Turing Machine was invented by Alan Turing in the year 1936. A Turing machine consists of an infinitely long tape which is divided up into cells. Each cell can be written with a 1, a 0 or an empty space. Above the tape is a head that can move left, right and read the symbols that is written on the tape. The head is also capable of erasing and writing new values into the cell. Let us consider an example wherein the head is in state 2 and if the data is 0, then it erases it, writes 1 and moves to the right, and then the head goes into state 5. The conditions written in state 5 is that if 1 is present, then it erases it, writes 0 and then moves to left, after which it goes to state 7. Let us consider an example problem. The problem given here is that if there is a blank symbol written, then nothing has to be done. If the symbol is 0, then it writes 1 in that place and moves to the left. If the symbol is 1, it writes 0 and moves to the left again. When these conditions are given to a Turing machine, it gives us a program that toggles all the binary digits from 1 to 0 and 0 to 1. Let us go to another example. In this example, there are 3 different states in which the head can be: A, B and C. According to condition, when the head is in state A and the input symbol is 0, it does nothing and moves right and stays in the state A. When it reaches 1, it does nothing, moves right again. When it receives a blank space, it moves left and goes to state B. When it receives an input symbol of 1 in state B, it changes it to 0 and moves to left. And when it receives an input symbol 0, it changes it to 1, moves left and goes to state C. In state C, when it finds an input symbol 0, it does nothing and moves right. And when it finds a blank space, it halts. Let us consider a DFA on binary incrementing. Let us consider an input string 1011. When the head receives 1, it moves to the right and goes back to the same state. When it receives 0, it moves to the right, goes back to the same state and repeats it until it finds a blank space. Once it reaches the blank space, it starts moving to the left. When it is moving to the left, it converts all the 1s to 0s, and when it receives the first 0, it converts it to 1 and then goes to the final state. Now let us look at a DFA on a palindrome checker. Let us consider a string ABBA which should be accepted. Firstly, when the DFA receives the input symbol A, it goes into the have A state and moves to the right. It has a self loop until it finds a space. Once it finds a space, it goes to the left and checks if the input symbol is A. If it is A, it goes to the back state. Here, it goes to the left until it finds an empty space. And then, once it finds the empty space, it goes back to start and then starts moving to the right. This process is repeated until the string is empty. Once the string is empty, it goes into the accept state. Now let us look at an example of a DFA of a palindrome checker where the example is not accepted. As you know, in the DFA of a palindrome checker, it keeps eliminating the input symbols from either sides. If the input symbol eliminated at the beginning is not same as the input symbol at the end, then it goes into the rejected state, as shown in the video.